Hi, my name is Jeff Reedy, and I work in Ed STEM Learning at Sonoma State University. Today, we are assembling a rocket payload for the N3 project. The following set of videos are compressed to save tutorial time. The time it will take you to complete your payload can take anywhere from 1 to 6 hours. So take your time and work at your own pace. Be sure to double check your work as you go. By the end of your build, you should have a fully functioning payload. I want to take a brief moment to kind of talk about all the parts that are included in the kit. So not all of them are displayed here today. Only the payload parts are displayed here. But what is included in the kit is the Big Daddy rocket with nose cone modification and the payload parts box, which looks very much like this. So just wanted to show you the payloads parts box. And inside of that box, you'll get a battery compartment, 3 AAA batteries, a slide switch, 2 3D printed sleds, 6 colors of wire, 10 440 screws slotted, 4 3/8" standoff, 4 1" standoff, 8 rubber washers, 1 9° of freedom sensor breakout, 1 3.3 volt regulator, 2 proto boards, 1 TMP36 temperature sensor, 1 SD card breakout, 1 SD card, 1 SD card adapter, a 90° male header, 6 pins, 1 3-volt Arduino Pro trinket, 1 male header pin strip, 2 12-pin female headers, 1 7-pin female header, 1 5-pin female header, 1 4-pin female header, and finally 1 3-pin female header. And the tools provided will be glue, a screwdriver, a soldering iron, solder, helping hands, a hobby knife, wire stripper cutters, sandpaper, and an FTDI cable. I also recommend that you either have electrical tape or Scotch tape if that's more convenient, a pair of scissors, and a pair of pliers, needle nose. I find them helpful at times. And a digital multimeter to do testing, so something like this. Okay, so all the parts that have to deal with the battery board we'll be setting aside. And all the parts needed for the assembly I will set aside. I'll take this moment to kind of do that right now. Okay, so now I have the Arduino, one proto board, 1 3.3 volt power regulator, 1 TMP36 temperature sensor, and 1 9° of freedom sensor, and the SD card breakout. And of course I have the wires necessary to cross connect all these parts with the Arduino. So we're going to begin with assembling the Arduino. The Arduino in this closer view is 12 pins across the left and right on the PCB board, with 6 pins for the FTDI connection on the bottom. We'll begin by soldering the 90° header pins. So these are the pins that we're going to solder onto the header. So this is the top of the Arduino, and this is the bottom. Okay. I'm going to start by inserting into the top the FTDI header pins. And I'm just going to kind of rotate it over so that it's now kind of sitting on my mat. Okay. So as you can see in the camera's point of view, the pins are kind of sticking through the header here. So now I'm going to look for my solder. So here's my solder. I'm going to hold it into my left hand like so. And on my right hand, I'm going to hold the soldering iron. By this time, it should be nice and hot. And the way I'm going to kind of approach this is I'm going to come in one side and heat up the pad on the PCB board for the Arduino and heat up the pin of the header pins. So I'm going to do the first one, and then I'm going to go to the last one. So once I got the first one soldered and the last one soldered, I'm going to work on the ones in between. So now we have nice shiny solder on the bottom side of the FTDI header. So now I'm going to insert through the bottom the headers for the Arduino itself. Okay. And I would highly recommend using, if you're not familiar with doing this, the helping hands. I'm making sure that the pins are lined up and squared off. Now take the soldering iron and solder the first and last pins. Then solder the pins in between. Do one side and then the other side. We're pretty much done soldering these points. I'll inspect them. Basically, you want to make sure that the solder joints are solidly connecting pins to the PCB pads. You basically want to ensure that you don't have any problems later. Now that we completed the assembly of the Arduino, we'll work on the SD card. So I just wanted to show you real briefly what it looks like. Here's a nice part of the video to show you what the SD card looks like. We're going to put links on this card. So starting with our male header pins, we'll count off 7 pins and break off the rest. So you could either use your strippers to help with the breaking off part. So here we go. So I will count off 7 pins. So 1, 2, 3, 4, 5, 6, 7. Okay. You can also use needle nose pliers if that's more helpful to you and you have access to it. So I will break off on the other side here, like so. Like that. And to verify that we've broken off the right amount, I'll go ahead and insert the headers into the breakout. And as you can see here, we appear to have broken the right amount of pins for the header. So one more time, just like that. Okay. We need to solder this in place. So using the helping hands, I will orientate them so that the helping hands will actually help us hold the pins in place. And I will reorientate the little camera so you can see me do my solder work. Now that I have the helping hands holding the assembly together, I will solder it in place. So just to kind of verify that everything kind of looks squarish, I'll get out my solder. And my soldering iron. And I'll come in on each side. Okay. And we're going to take a moment to kind of inspect the work. Looks pretty good. And we'll move on to soldering the 9 degree of freedom sensor. The only parts that we're going to use from the 9 degree of freedom sensor kit is the header and the breakout, the sensor breakout board. Okay. So with the help of the helping hands, there. Okay. So that looks pretty square to me. And we can go ahead and solder the header pins on the 9 degree freedom sensor. Okay, so we'll do a quick inspection. And it looks like we did a pretty good job soldering on the header pins on the sensor. So I'll set that aside. And the last component that I'll need to solder the legs on is the 3.3 volts voltage regulator. And the only components that we're going to need from the bag is the header pins and the voltage regulator. So I will clip this on the helping hands and slide on or slide in the header pins. Okay, so I'm just try to rotate this around so you can see it a little bit better. I'm going to try to make sure this is as, squared up as possible. It's about like that. Looks okay with me. And this one's a little bit tricky. The components are much closer in, so to the solder points. Want to make sure that you don't accidentally desolder any of these other components on this board. Okay, so I'm just going to do a quick inspection, and that looks pretty good. I may want to hit that second pin over just a little bit more, make sure that it has a fair amount of solder in place. So I'll check that. Like that. Okay. So this looks pretty good. And this completes putting the header pins on the individual components. Now we'll move on to testing the Arduino. Make sure you have the Arduino IDE already started with the Hello World sketch open. So now we're ready to plug in the FTDI cable into the Arduino's FTDI pins. Go ahead and connect the header pins with the header. Once connected, plug the USB portion of the cable into the USB port on the computer. Okay, now we're going to upload the source code to the Arduino. Okay, so again, the source code that we're using is the Hello World source code. You want to make sure that this is open in your Arduino IDE. So we're going to go ahead and upload this code into our Arduino, and we're going to do that by going to the upload button. So we're going to go ahead and upload this. It's going to recompile, and it's going to send the code into the Arduino and reprogram its memory. Okay, so it looks like it's done it successfully. We did not get any kind of errors. I'm going to go to the serial monitor, and I'm going to open it up. So assuming that we did everything correct up to this point, we should be getting Hello World being processed by the Arduino and sent back to our console. And as you can see, every once in a while there's a little red light that kind of prompts up, establishing the communication. We're powered, so we're definitely able to communicate with the Arduino device. Okay, before we begin with soldering anything on the proto board, I want to point out a couple things. Wherever you see lines on the proto board, it connects those parts. Okay. So for this row, it's all connected. All these pads are connected together. And this is the same going up and on this side of the proto board. The next thing I want to point out is this column. This column on the outside and this column on the other side. These are referred to as your ground rail, and they're connected to all these pads. So like this one here, that's square. This middle set of pads, this column here, this is called your power rail. And this is connected to all these round pads. You'll notice on the top, you'll see these connections across. This will connect specific pins on the Arduino to whatever connection that you connect to this column here. So now with that in mind, you'll notice that this is labeled top and the bottom board will be labeled bottom. Okay, so now we need to solder on our 12-pin female headers to connect our Arduino to the proto board. So we'll start with, this is what one 12-pin header looks like. Looks just like this. And we're going to solder it here. So we'll have one on these set of pads here and another one on these set of pads here. Notice the orientation of the board, it's top. Where we want to solder these is to the top of the proto board. This is how we want to solder it in place. And we'll solder it on the bottom side of the board. But before we can do that, I want to tape these in place. So I will use my trusty Scotch tape. These headers are as square as possible so that we don't have issues plugging the Arduino in. So this looks pretty good here, like so. And with my trusty helping hands, I will rotate this around and have them hold it in place. You can also set this down on top of the table. That should be sufficient. All right. So I will just go ahead and solder these in place. It'll take a little bit of time. Take your time while doing the soldering. You don't want to make too many mistakes. Again, we'll start with the first pin and then end at the last pin, and then fill in the ones in between. So what we want to do is make sure that they're good solder joints, and they'll have good connections to them, to each of these points on the Arduino. So now you can see that it looks pretty square. And for the most part, the solder joints are pretty good looking, so these headers will work fine. This brings us to the point of soldering on the header for the SD card breakout. And so we'll take the 7-pin header, and I usually like to put it in the middle of the rows. It gives you some extra pads on either side to solder things in place if you need to. I will take the piece of tape that I used for the headers, and I will tape this 7-pin female header in place, and we'll solder it on the back side. I'll rotate this over. I don't think I need the helping hands, so I'll just rotate it over and just let gravity kind of do its thing. Now we will solder the header in place. Again, we'll inspect the solder joints. They look pretty good, actually. So take note of the various different connectors or the pins on the SD card breakout. We will need to make sure that we connect them to the appropriate pins for the Arduino. So I want to start with the connections that connect us to the power rail and the ground. Those are the easiest connections to make, so we'll do those first. And the third pin up will connect to, is called VCC, and it'll connect to our power rails. So we're going to take this row, 3 rows up, and bridge the connection here. So I'll take a little piece of red wire and go ahead and cut it off. And we'll strip off both ends. You can use strippers or pliers to bend both ends of the lead. So I'll grab that end and bend it down. And if we did this right and kind of measured out the distance, it should fit in. So we'll go ahead and try it. And it looks like that's a pretty good fit. Okay. And before we tape it in place, we want to make sure that in accordance to our SD card, third one up connects to the VCC. Third row up connects our VCC, like so. So that looks good. Go ahead and tape this in place. So I'll grab my trusty soldering iron, and we'll solder these this lead in place. Now we need to work on the ground, referencing our SD card breakout. Is third from the top. So 1, 2, 3. Okay, I'm going to count it off. 1, 2, 3. So we want to bridge these two connections here. So I'll cut off a little piece of black wire. We'll bend the ends of the lead and end up with something that looks like this. So 3 from the top, 1, 2, 3. Bring it back into the image here, or the video. So, and we'll solder the lead for the ground. So I'll take my tape, and flip the board to the bottom, and the leads that we're going to solder, or the pads, I should say, is this one and this one that we see a little bit of the wire poking through. So I will solder this pad on the ground rail. Okay, that looks pretty good. And I'll do this other pad here. Take your time. This is really delicate, hard work. Okay. So now let's inspect our joint, and the joint looks pretty good. Okay. So now we're ready to start doing the rest of the running of the data lines. We'll work from the bottom to the top. The only pin that isn't used is the CD pin. Okay, but everything else is used. So the CS is this very bottom one. It's pin 1 on the bottom. We're going to run that with orange wire up to this pad on the proto board, which is pin 10 on the Arduino. We're going to take a length of orange wire and kind of measure it out. We'll go ahead and clip off the length we need. Okay, we'll strip the end. Okay, and we'll do the same with the other side. So I have one side strip. And then the second side strip. And again, you can take your stripper and on the end kind of bend it. And I'll do the same with the other side. Like so. So I think what I will do is run it like this. Okay. So now we're connected, well, actually, yes. We're connected to the first pin on the SD card breakout, and at the top we're connected to pin 10 on the Arduino. Okay, and what I want to do is I want to tape it in place now. We'll do the solder job. Now we need to solder these in place. Okay. So starting with the SD card header, Okay, that looks pretty good actually. The next one up is our DI. Okay, so that's this pin, and DI connects to pin 11 on the Arduino. Now I'll measure some green wire out. Want just use enough needed to do the job. So something like this length looks pretty good. I'll cut it off, cut off the length that I need, and I'll strip both ends. So we'll go ahead and strip both ends. You can bend the wire like so. And we'll do it at both ends. So now we're going to run our green lead, which connects the DI to pin 11. I will go ahead and tape that in place. Might be necessary to get new tape. That's perfectly okay. So I'll tape this end in place. And tape this other end. So now this is the lead that we're going to solder near the breakout. And be careful when you're working this close to the header. It's very easy to melt the plastic. So we'll rotate this around and solder 11. SCK connects to pin 13 on the Arduino. Okay. It is the connection, so it's 1, 2, 3, 4 up. So 1, 2, 3, 4. So we're going to connect this pad to pin 13, which is here. Okay, so 10, 11, 12, 13. For this, we'll use the yellow wire. So I'll kind of measure out the amount that I'm going to need. Cut off the piece and strip the ends. And we'll go ahead and bend the ends like so. Okay, so now we have both ends bent. I will place my yellow lead where it needs to go. So we count up 1, 2, 3, 4, and run it to pin 13 on the board like that. I'll go ahead and tape both ends in place. So now we'll solder those leads together, and I'll rotate this around, and we'll solder it in place here on this pad that connects to pin 13 on the Arduino.
Now, let's do DO, which is second from the top.
Like so. So we want to get the row that represents this pin. So second from the top. That's 1, 2. It's this one here that we want to use. So I want to connect this pad here to this pad here, pin 12. Okay, so we'll use blue wire for that. Okay, so we'll cut out some blue wire, make sure that it's about the right length. And strip both ends. So now we have the appropriate places that are bridged. We'll tape those in place.
Now we'll solder both ends in place.
So now we need to work on placing the header for the 9° of freedom sensor. We'll take the 5-pin female header, like so. This is what our sensor is attached to. I'll place the header toward the top of the rows. So on the bottom of the proto board.
Now I'll tape the header in place. Next, we'll solder the header in place.
And when we place the sensor, it will be mounted like so. Okay. So the thing of note is note the orientation. Okay. So I want to start with the ground and the VCC. On this sensor, the VCC is on pin 1 and the ground is the last pin. So we want to bridge this connection here. Here, let me tilt it up so you can see it a little bit better. Want to bridge this connection here, and then bridge this connection here.
We'll cut off a small piece of wire, strip it at both ends, and bend both ends down, and bridge the connection between the power rail and the pad.
Okay, so now where the 2.6 volt is connected, it's now connected to the power rail. So we'll go ahead and tape that down. So now I will solder that lead in place.
Next, I'll fabricate the connection for the ground by cutting off a piece of wire, stripping the wire at both ends, bending the wire to fit.
It's now bridged. We'll tape it in place and solder it. We're going to solder these two bits of wire to the associated pads. So I will do that right now.
Now the ground is connected. We look at the sensor's placement on the board here, like so. So far, we've connected the 2 to 6 volt VCC to the power rail and the ground. So the next two connections are the SDA and SCL. We want to run a green wire from SCL to A5 on the Arduino and SDA to A4. We'll run from SCL, which is 3 from the top, 1, 2, 3, all the way to A5, and A5 is here on the board. So I'll trim off a little bit more so that I have a little bit more than I need. Strip off the end. And bend the end in place, like so. Okay. So now we'll go ahead and connect this together, like so, and we will solder those leads. Like that. We're going to cut off and run our yellow lead. So I want to kind of measure it out. This is about a good length right here. So I'll cut that off, strip it at both ends, and bend down the lead. Go ahead and place the lead and connect it to A4, like so. Now we are connected from the pin that's SDA to A4. We'll go ahead and tape this down at both ends. There we go. So we're going to solder this pin to this pad and this wire that's kind of poking through over here. So this completes the header for the 9° of freedom sensor. Okay, so the last thing we're going to do is put in our 3-pin header for the temperature sensor. So let me rotate it here. We will place it like such. Carefully place the header on the proto board at the bottom end, toward the bottom end. Okay. And solder it in place. So we'll go ahead and do that. Okay. So these 3 pins we're going to solder in place from the header. Here, here, and here. They're in place. Like so. We need to place our temperature sensor. So here's our temperature sensor, and here's our header. We place the flat side out. Our middle pin is our signal, and we'll need to run a yellow lead from it. Our top pin
we will connect to the ground rail. And our bottom pin, pin 1, if you want to think of it as such, this might be 1. So 1 is ground, 2 is signal, and 3 is VCC. We'll bridge these two connections here. Okay, so we'll start with the ground and the VCC. I'll cut off a little piece of red wire to connect the VCC. So like so. And strip both ends. I'm going to bend the wire like so. And we'll do the other side as well. And so what you end up with is a lead that kind of looks like this. It should fit right into this first connection here, like so. Okay. I will tape that and solder in place. Now we'll do the ground. I will cut out the piece and strip both ends. And place it into our pin 1. So I'll go ahead and do that right now. So now we bridge the connection. I will tape it in place. So we'll solder that in place. So now the last thing we have to do for the temperature sensor is run a yellow wire from one of these two pads. It could be any of these pads really, but it's this middle pin to A3 on the proto board. So I'll measure out a piece of yellow wire that will connect those 2 points. I'll cut it and strip both ends. Once you kind of get it, tape both ends in place. It'll help you keep the wires placed as you solder. The lead we're going to solder is this one here. Move this a little bit closer so you can see it a little better, I think. All right, so this lead here and this lead here. So we'll solder that in place. That looks like a good solid solder joint. And we're all connected up now. Okay, so we can assemble this. We'll start with the temperature sensor. And we'll kind of push it in place with the flat side out. And I usually like to bend down the temperature sensor, like so. Okay, so it's nice and flat like so. And then we'll insert our 9-degree of freedom sensor. Okay, like that. And then we'll go ahead and insert our SD card reader, like so. And then finally, we'll go ahead and insert our Arduino, like so. What you should have is the finished part of the Arduino board with your sensors all placed. Now that we have the SD card reader connected and wired up properly, we're gonna test the code out on it. I have the SD card in the reader now, and I have the FTDI cable connected. So now I'm gonna go ahead and plug it in. So let me do that. Okay, and we see that we have a light connectivity with the serial connection with the FTDI cable. And the source code that we're going to look for now is the SD card source code. So I'm going to go ahead and load that. Okay. So now that we're connected to the Arduino, I'm going to go ahead and just compile the code and check the sketch. Looks like the sketch is checked okay. I'm going to go ahead and upload this into the Arduino and then open up the serial monitor. So we're going to compile it again. It's going to upload, and I see that there's a lot of activity that's happening on the Arduino board. I'm going to go ahead and open up the serial monitor. And as you can see, I'm just going to undo the auto scroll here. That the SD card was initialized, meaning that it was able to open up a channel to the SD card, and is in fact writing data to the card. And we can confirm that by, I'm going to go ahead and close this and unplug the FTDI cable and remove the SD card and put it in the adapter. So that's what I'm going to do right now. I'm going to open it up in my computer, and we're going to navigate to where the SD card is located. And we could see that here is our myfile.txt. And if I open that up, we see that there's a whole bunch of hello world printed to the file. The Arduino is communicating with the SD card, and the code works. Okay, now that we have the proto board assembled with the SD card reader, Arduino, and a 9 degree of freedom sensor, we're going to run the code to test the sensor. So look into the source code and look for the folder 9DOF ICM 20948. That will be the code that you'll load into the Arduino to read from this sensor. Okay. Now we have the code up. I'm going to verify the code. It's going to compile it to make sure that all the header files can be found. Okay, that's cool. We're going to upload that into the Arduino. And we can see a lot of activity happening on the Arduino as it's uploading. Okay, very cool. We're going to open up the console. And as you can see, let me stop this auto scrolling for a moment. It'll show you that the 9° of freedom sensor is connected and the magnetometer is connected. The code will ask you to lay the sensor flat, and so it can calibrate. Once it's done, it'll loop through and do measurements of the gyroscopic rotation, the acceleration in each direction, and give you the calculation in total G's. And it will return the magnetic field density in all three directions, X, Y, and Z. So if I turn on auto scroll, you can see it's actually changing as I'm rotating around the sensor. So finally, we're going to test the temperature sensor. And the code for that is in our source code folder. So I'm going to go ahead and look for it. We're looking for a temp sensor. So I'm going to open up the INO file. Okay, there we are. I'm going to connect my Arduino to the FTDI cable, so allow me to do that. Okay, I see that my Arduino is active. And here are my sensors on the back side of the board. I'm going to check the source code by clicking the verify button, and now I'm going to upload into the Arduino. So I'm going to go ahead and do that. You should go through the process of calibrating your temperature sensor. I'm not doing that, so my numbers will probably be wrong. I'm just going to check and make sure that it works. So now I'm going to open the serial monitor. And if I put my finger on it, it does in fact get warmer. Now that we see that the temperature sensor is working, this concludes the testing of the temperature sensor.